So an exponent is a number or variable that indicates how many times the base is used as a factor. So it's going to be the small number in the top right corner. The base is going to be the number or variable representing the factor being multiplied. So it's going to be the main number being multiplied. Equivalent means equal. An expression is a math problem. So if you hear me say the word equivalent, I'm saying it's equal. If you hear me say solve the expression, I'm saying solve the math problem. A base, let's say this is the base, this would be the exponent. So the big number is the base, the small number is the exponent. Let's say I have 3 times 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 3. That's a lot of 3's, isn't it? So 3 is my base. What would my exponent be for this first set of parentheses? 4. 3 is my base. What's my exponent for the second set of parentheses? 5. So you're multiplying exponents here. When you multiply exponents, you just add them together. So what's my base? 3. How many 3's do I have up there? 9. 9. I just said 4 plus 5 is 9. So when you multiply exponents, you add them together. For this first set, how many 7's are there? 6. And what's my base for the second set? 7. And how many are there? 3. So you have 7 to the 9. Do I need to go over this again? What if they do something like this? We can use the same principle, can't we? What's my base here? X. And what do I do to m and n, even though I don't know what they are? Add them. So I would just do m plus n. Can I solve it? No, but if they told me what x, m, and n are, I could solve it. I could just plug them in. I could substitute them in and solve it. So that's all I'm doing is I'm taking my base and I'm adding the exponents, correct? What's my base in the first set of parentheses? How many exponents do I have? 11. What's my base in the next set of parentheses? 4. And what's my exponent? 9. And what's my base in the last set of parentheses? 7. Okay, notice that I did not put a sign between any of those. I didn't put a time sign or a parenthesis. Because if you have a base with an exponent and then another base with an exponent, you know you can't add them. You know you can't subtract them. It's understood if they're just next to each other like that, a base with an exponent that you're multiplying. If you wanted to, you could have put a time sign between them, but you don't have to, and sometimes in math they won't. Sometimes it's expected that you know you have a base with an exponent, another base with an exponent, you're multiplying. Okay, the first set of parentheses, what's my base?
3.
What's my exponent?
6.
Second set?
2. 13. 6. 5. 8. 2.
If you wanted to put a time sign between there, you can, but you don't have to. So when we multiply exponents, we added them. So if we divide exponents, what do you think we're going to do? Subtract. So let's say you have 5 to the 5th divided by 5 to the 3rd. And this is a 7th grade skill that the 7th graders will be learning. Just a reminder that this line right here means divide. If you run out of space, turn the page. So if I look at it like this means 5 times 5 times 5 times 5 times 5, correct? The bottom means 5 times 5 times 5, correct?
Yes.
So if I don't understand how to do it, I can write the whole problem out. You know when you have the same number on top, the same number on bottom, if I cancel one of these out, I can cancel one of these out. So let's look. Cancel out, cancel out, cancel out. I'm left with 5 to the what?
Second.
Second. Or, if you want to do a shortcut, 5 minus 3 is 2. Okay, if I have 3 to the 7th divided by 3 to the 4th, I know I could write it out. These can cancel out, and that leaves me with 3 to the 3rd. I can do 7 minus 4 is 3 is a shortcut, right? Sometimes that shortcut doesn't work, and let me show you. What if I have 4 to the 3rd over 4 to the 5th? That means I have 3/4 on top. I have 5 on bottom. Uh-oh. It's supposed to be what? Those cancel out. There's nothing on top and there's 2 on bottom, correct? Well, if there's nothing on top, I put an imaginary 1. So, 3 minus 5 is -2. And you can never, ever, 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 never, 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 ever, ever, ever have a negative exponent. Can you have a negative exponent? No. So if you have a negative exponent, you can't have it. So you would have to flip it upside down and put a 1 on top. Is that what we ended up with here?
Yes.
Yes. It is against the law. The math police will come and arrest you and say you've broken the math handbook if you have a negative exponent. Get rid of it. You don't want it. It's bad news. You want to flip it upside down and put a 1 on top. So mathematically, this is what it looks like, correct? So if these cancel out, what do you put on top?
1.
And what goes on bottom?
5.
Or if you did it this way, you said 3 minus 8 equals -5. Can you have 5 to the -5?
No.
So you flipped it, you said 5 to the 5th, correct? Because can you ever have a negative exponent? No. So what if they try to really trick you and they say like something like this? What's your base?
X.
X. And what are you doing to M and N? Subtracting them, because you're dividing. So if they give you something like this, all you want to do is work with the common bases. So, you know you have 5, 4, and 7 as your bases, correct? It's dividing, so what are you going to do to those exponents? Subtract. You do 3 minus 4. Can I do 3 minus 4? No. So we know it's going to be negative, right? 3 minus 4 is what? -1. 5 minus 3 is what? 2. And 2 minus 5 is? -3. Uh-oh, I cannot have negative exponents. So what's going to have to go on bottom of my line? 5 to the 1st. What else is going to have to go on bottom? Times 7 to the 3rd. What's going to go on top? 4 to the 2nd. 1 doesn't go on top this time because I have a number up there.